Where? To pi over 8. So normally, I'm just up here, I'm just going to do a quick sketch. This is what I would sketch for a sine curve, right? Two things. First of all, this one's got a negative in front of it, which is going to turn it upside down. And it's been shifted pi over 8 to the right. So I have pi over 8. I have a negative sine curve that starts at pi over 8. Would everybody agree with that? Now I know because of the 3 that my hills and valleys are going up 3 and down 3. And now I'm pretty much done, except I have to figure out what all these labels are. Well, I guess there's a few other things to worry about too, but let's get these labels taken care of. Now, those labels are going to depend on how long this curve is. Would you agree with that? That's called its period. What is the period under normal circumstances? We need to know this. The period under normal circumstances for a sine, a cosine, a secant, and a cosecant is 2 pi. 1 revolution, 2 pi. But I've done something here. I've put a coefficient on my x, which divides my period. So my period is twice as long as it normally is. So from this dot to this dot would be 4 pi. All right, so what's the label on that dot going to be? Do not say 4 pi. It's not 4 pi. What is the label on it going to be? 4 1/8 or 33/8. I like those mixed, or those improper fractions, because I'm going to need it to find the rest of these points in here. Okay, so where did 33/8 come from? It's 1/8 plus 4, 4 1/8. Now this is right in the middle, which would be the average of 1 and 33. What is the average of 1 and 33? 1 plus 33 is 34, and half of 34 is 17. So 17/8 there in the middle. This is the average of 1 and 17. What's the average of 1 and 17? 9. And then the average of 17 and 33, which is 25. And then I told you, if you wanted to take the time, make sure these are all the same distance apart. Looks like you're from 1 to 9, that's 8. Another 8, another 8, another 8. Looks good? Now that is super if this had been the problem. But it wasn't a sine, it was a cosecant. And then I need to deal with that. But first, I need to take care of the cosecant part. To get the cosecant, it's very simple. Draw an asymptote every time your sine crosses the x-axis. Every time you have a 0, an x-intercept, draw an asymptote. And that's because the sine is 0 here, so the cosecant would be the reciprocal 1 over 0, which is undefined, and undefines are graphed as asymptotes. So every time you cross the axis, you're going to pop in an asymptote. Okay? Then you're going to take this valley right here, and you're going to turn it upside down. So it becomes, you're going to reciprocal it. It becomes that parabola. Just take that valley, and go like that. And then guess what's going to happen to this hill? It's the same thing, only it's going to fold up. It's going to look like that. So your cosecant is exactly the same as the sine curve. It starts as a sine curve, but you drop in the asymptotes and then flip the hills and valleys to make parabolas opening up and down. Now, what about the +2 on the end? What's that going to do? Shift it up 2. It's a vertical shift. It's going to take it up 2. So this guy is coming up to here, and this guy is coming up to here. So the green is actually the answer to the question. Now, you don't need to erase. You can if you want. If it confuses you to have all that stuff in there, go ahead and erase. You can leave it all in there. Just make sure I know what your final answer is. Okay, by either using a highlighter or shading it heavy or something. Now, in addition, on test day, which will be in January, when you graph one of these, you will have to tell me the amplitude, period, phase shift, sometimes called horizontal shift, and vertical shift. You'll have to give me that information. It's something called frequency too when we get to that. All right, so here we go. Let's fill in those things for the picture that I drew for the cosecant. Does it have a vertical shift? Yes. How did I shift it vertically? Up 2. Now you can write up 2, or you can just put 2. A positive 2 would indicate up. If it were down, you could write down 2 or negative 2. How about phase shift or horizontal shift? Did I have one of those? Yep. What was it? Positive pi over 8, or you can use the word right pi over 8. Positive pi over 8 or right pi over 8. In order to graph it, we calculated the period. We said the period was 4 pi, right? Now here comes the tricky one. I know what you want to put down for amplitude. I do too, everybody does, but you can't. The secant and cosecant have no amplitude. And they have no amplitude because they don't have a top or a bottom. They go forever and ever and ever. Now, remember, when we said the amplitude was 3, what did that mean for the sine? What did that mean? The hills topped out at 3 and bottomed out at -3, right? That's what amplitude means. When you take that away and you start doing stuff like this, you have no amplitude. Now, is the 3 still important? Oh yeah, it was hugely important in drawing the picture, but it's not called the amplitude. There isn't an amplitude. All right, you okay? We're going to try secant now. Anybody have any questions about this guy before I start erasing? Okay, then let's do a secant. Does anybody have an idea how I might draw a secant? Let me put one up here. I won't make it quite as horrible as that one was. Let's say 4 secant 2/3 x. We'll just do that. Any ideas how we might start? Thinking of it as a cosine. Very good. We're going to go ahead and sketch a cosine. And this is comfortable territory for us. We know what cosines look like. Cosines go from the top of the hill to the top of the hill. That's what a cosine looks like. Now, if you don't know that's what a cosine looks like, you have issues you need to get resolved. All right, so tell me about this cosine. Does it have any phase shift, horizontal shift Or does it start right up here at the top of the hill on the y-axis where it's supposed to? Is there any shift? Starts right there, just like it's supposed to. There it is. There's my cosine. From top of hill to top of hill. There it is. How do I know there's no phase shift? What is not up here? A parentheses with a plus or a minus in it, right? I know this is 4 and this is -4. Would you agree with me? I'm all done except for these labels here and dealing with the secant part. So what do those labels depend on? How long it is, right?
Yeah.
Which is its period. What is the period of a cosine supposed to be? Like normal here, that would be 2 pi. But I put in a crazy number. So this period will be 2 pi divided by 2/3, which is 2 pi times 3/2, which is 3 pi. Now that means dot to dot is 3 pi. Can I label this 3 pi this time? Yeah, because I started at 0. There's no shift. I didn't have to worry about starting in a different spot. This would be the midpoint. So the midpoint would be 1.5. I prefer personally 3/2, but certainly 1.5 is fine. This is the midpoint of 0 and 3/2. That would be 3/4. Wouldn't that be 3/4? So I got 3/4, 6/4. This would be 9/4 and 12/4. That is a beautiful picture, but it's not a secant. So, drop in some asymptotes. Where are the asymptotes going to go? Where I cross the axis. So that's going to be here and here. Now what do I do after I get the asymptotes put in? I start making the parabola. So this is the easy one. These guys sometimes confuse us, so we need to keep in mind the cosine is an infinite graph. It keeps going forever and ever. So if I drew more of it and flipped it, I can see this parabola, right? The problem is I only have half of it drawn. And similarly over here, I only have half of it drawn, the other half would be over here. So you've got your down parabola, and then you got 2 halves of your up parabola. And that's it. There wasn't anything else going on in this equation, so that's it. Let's fill in our blanks. What's the amplitude of this green picture now? I'm looking at the green one, the secant. What's the amplitude? There is none. I'll give you a little hint. The only functions that have amplitude are sine and cosine. The only trig functions are sine and cosine. Everything else has arrows that shoot up or down. We said our period was 3 pi. What's our phase shift? What did we say our horizontal shift was? There wasn't one. So 0, 0. And vertical shift? 0. Didn't move it up or down at all. Alright, now we're going to do 2 more problems, and then I'm going to let you go to lunch. I know you're just chomping at the bit. But then when you come back, we can start reviewing, okay? So we're going to do a tangent and a cotangent. Who can tell? Tangent and cotangent are totally different pictures, right? you tell me what a tangent looks like? What does a tangent look like? Which one of your BFFs? It's not a BFF, but it looks like one of the BFFs. Which one does it look like? Which one? Looks like a cubing function, doesn't it? The tangent, what you have to have memorized is that a tangent has an asymptote at negative pi over 2, positive pi over 2, and increases through the origin. That is what a tangent looks like. That should not be new news to you. That was on your sheet. That shape. So now I'm going to have you do this. Okay, so we're drawing that. Okay, this is what we're drawing, but we've made some modifications to it. So tell me what modifications I have made to my tangent curve. What has changed? It's gone to the left, pi over 12.
This is Ford.
Yep. Yes.
May I have Costanza Liddell to the front office for dismissal, please?
She's on her way.
Thank you.
So we're going to take this pi over 12 to the left. What does that mean? That means that this dot right here that was at the origin is now over here. So I got an asymptote, and I got an asymptote, and I got my curve increasing, but now it's increasing through the point negative pi over 12. Yeah. Now you are done, except you have to tell me where those asymptotes are. Okay, now let's look back at the original. How far apart are the original asymptotes? One period, this section right here, how far apart are the original asymptotes? 1 pi. So normally the period of a tangent and a cotangent is pi. Okay, wait, that's different, isn't it? Because for sines and cosines, it's 2 pi. For tans and cotangs, it's pi. Okay? Now, what have I done, though? I put a coefficient in there. So the period, the distance from here to here used to be pi, but now it's going to be pi over 2. Right? It's half as big as it was before. So this whole distance is pi over 2. How in the world am I going to figure out what these asymptotes are, what these labels are? How am I going to figure that out? Any thoughts on that? It's easy. What? Okay, so that would be 6/12. You're talking about with that point. So the distance between the asymptotes is 6/12. Oh, wait a minute. It's starting to get crystal clear. That's right in the middle. So if the whole thing is 6/12, then I'll just add 3/12 and subtract 3/12. And you got enough to worry about. If you want to reduce those, fine, but you don't have to. Okay? Alright, well when you come back we'll do our cotangents. You all keep watching the clock, not paying attention to me anymore. Yeah, right, you're starving to death. Alright, when do we need to be back? It's 11:47. We need to be back at 12:22. 12:22 in your seats at 12:22. 22.